should please tell them that they must join with their registered account, because you have all joined with your registered accounts without waiting room, right? I still see there are several people in the waiting room, and I hope they join with their account. There will be no need for us to approve you coming. So we'll wait for a couple of more minutes for everyone to join. There are a few people who are still stuck in the waiting room, but let them join via their registered login. So any we can start discussing any questions that people may have. Okay, just give me 1 second. Okay. So any questions, anyone from the previous classes so far? This is the 4th week of the course, right? Yeah. Yes, Nikita, you have a question. Go ahead. Yes. Switch on video if possible.
So can you hear me?
Yes, I can. Yeah. And Nikita,
yes. Can you hear me?
Yes, yes, yes.
Yeah. So I was wondering, what would you call if you perturb the growth rate and saw what happened to the model? That would contribute to how robust the model is?
Oh, perturb the growth rate itself. Oh, that's a very interesting question. Okay. Yeah, that's a great question. So what we were doing in terms of perturbation was we were perturbing from an equilibrium state, all else being equal, right? What you're saying is, can we perturb the parameter like R0, right? Right, that's the second way of doing it. That's a very good way of thinking about the issue. Now it's not just is it stable to small perturbations in the state, but perturbation to the parameter value itself. One can actually go a bit further and ask, what about perturbation to the entire growth function, right? So when I say growth function, I mean the right hand side function, the f of n that we wrote. How stable is or the entire model properties for perturbations like that? So all of them are actually very valid questions, and what we have done is the most basic perturbation. Given that there's an equilibrium state for a given parameter value, what is the stability of the equilibrium? Okay, that's a great question. Yeah. So what that perturbation to parameters tell you how robust are your model predictions, right? One is one we can ask for the first growth parameter alone will tell you how robust is the state to perturbations in parameters. And the next you can ask how robust the entire bifurcation diagram is to perturbations in the model itself.
Yeah, the thing is, actually in last lab, we misunderstood the second part of the exercise. We thought you wanted us to perturb the growth rate. So
R0. Okay. That's fine.
Yeah.
No, it's fine. I mean, I guess in a short time that confusion may happen. Okay.
But yeah, I think the results were more like in terms of conclusions, it was just the same. So that is why I was wondering, based on that, would you call it on the predictability of the model? Like, what is the difference between commenting on the predictability of the model and robustness? Like, just the
Yeah. So basically predictability we defined as how we considered in a very idealistic scenario where there is only an initial condition difference between two systems, and how close will their long-term predictions be, right? But you can also look at, as you are saying, we know our estimations of parameters will also be erroneous. We can ask how how robust are predictions to those? I think, one can generalize and ask the same question of, predictability to, not just initial conditions, but also to variations in estimation of parameter values. And again, you can ask one step further and ask, to the model itself. So I think, all of them are actually very valid questions. And if you are in the chaotic regime, the same result will come out of all of the scenarios, independent of where the error happened. Okay, so everybody is able to join. I think only Raghuram is stuck. Okay, let me just, maybe I think I have his number. Let me just give him a call and tell him what to do. Okay, then we can start. Yeah, we can start now. So any other questions? Any other questions from any of you? Okay, so if there are no questions, so let's start today's sort of assignment. So today, as I had mentioned, the focus will be on make empirical connections. Okay, so we have worked with this one model, discrete time logistic population model, and then we have analyzed this model mathematically. We have analyzed this model simulation or computationally, right? And we have a bunch of possible outcomes that are possible with this model, like extinction is a possibility, a stable equilibrium is a possibility, cyclical population dynamics is a possibility, and then there are chaotic trajectories also a possibility, right? Now, so there are all these, we call these predictions of the model. Okay, so now once we have a prediction of the model, what do you think are the next steps to make it biologically meaningful? What are the next steps you will take it to make biological connections, empirical connections? So one is, it relates to a question that Nikita just asked, how robust are these results to variations in the model, right? First, we assume somewhat arbitrarily that, the density dependent function is a linearly decaying function. We could have chosen an exponential function, right? And in fact, in the next assignment, I'm actually going to give you that. If you now, instead of linear decay, what if I had assumed an exponential decay? In the previous assignment, you had just done a rescaling of that model. I would now like you to find out the bifurcation diagram of that model. And I can tell you the answer right away that it actually will yield basically almost all results, sort of identical to what you found with the logistic population model. Okay, so you will find that. Okay, so that means that whether I take a linear density dependent function or an exponentially decaying function, the qualitative features of the model predictions are going to be same. Okay, so that's actually reassuring, right? In some sense, imagine that if I had a linear decay and if I if I made small changes, if it gave me dramatically different results, that means that the results themselves are not stable to changes in the functions I'm assuming, right? On the other hand, if the results are quite stable to different functions I choose, it gives you an assurance that fine, because real systems are not going to follow neat mathematical functions. So that means that if the results are robust to various alterations of the functions we choose, then the results probably could be found in the nature. Okay, so that's one thing you can do. One is, once you have a model result, the next thing you often do is how robust are these results to some of the models choices we made. When we're building model, we make a bunch of choices, and many of those choices are driven by our convenience, mathematical convenience, and sometimes it is purely arbitrary. So it's important to check how robust are our results to those choices we made. Okay. So that's one thing, part of it you will do in the next assignment. So what else do you think we need to do? Okay. So this is what we will think about today. So I would like you to start, we will form, we'll all go to the group out, breakout rooms now. So the way we will plan today's session is, the first part, the first question you will try to address is, to really make good empirical connections, you need to have a fairly sound understanding of the assumptions that you made, when you sort of, constructed this model. Okay. So the first step you need to do is write down carefully all the important assumptions. Okay. So that will be the first step you need to do today. So discuss within your groups, and take the example of logistic population model again, and write down the assumptions that you made. Okay. The second thing that I would then like you to do is, once you have clarity of the assumptions that has undergone to this, now that you also know the various predictions, how will you go about making empirical connections to this mathematical model? Okay, the second part. Now, second part I have intentionally left vague by saying, how do you make empirical connections? So I would like you to think, what will be your group's approach in making empirical connections? There is no unique way of doing it. There are many ways of doing it. So I want you to think about it and come up with strategies for making empirical connections. Is that fine? So two sort of, points to focus. And broadly, empirical connections is the focus. The first part of it is, identifying the assumptions of the model and writing them down. And the second part is to sort of actually now, make the think a bit more deeply on how will you make empirical connections. Is that fine? Any questions, any doubts on this?
So the question actually is like, how do we explain the experimental data, right, with our model?
You should think about it. So I would like you to think about it.
Yes. So the main question is this only, right?
That is one way of say. That is one way of thinking about the empirical connection. That is not the only way. Okay. Any other questions? Is the question I have posed clear to everyone?
Could you explain it again?
So I want you to think about how will you make empirical connections. So it's intentionally vaguely defined right now.
So we can assume certain things, like other than the assumptions you mentioned, those are like we can assume that we have performed this kind of experiment to have these kind of empirical delusions, or this kind of procedure we follow to, like, based on that we can give, right?
Yeah, so what you said is absolutely correct, but the only small rephrasing I will do is you will come up. So I will not say that you will assume the experiments you will do. I want you to think about the experiments you can do. Okay.
Okay. Do we have any vague idea about what kind of question we are trying to answer? to come up
Again, leave it. I'm leaving it to you. So some mathematical modeler has come to you and has shown all these beautiful results of the logistic population model. Okay, now that person wants to collaborate with you to do some empirical connections of the model. Okay, now imagine you have all the resources in the world at your disposal. Okay, now how will you go about doing this? Is it fine?
Yes, yes, thank you.
Okay, of course, just let me also make it clear. Just because you have all the resources in the world doesn't mean you sort of make it very, very complex. Simplicity will always be more valued. Okay. For example, if you were to still use the least amount of resources, that's always great. Okay. So don't be constrained in thinking, but of all possible things you can think, always keep it simple. Is that clear? So, okay, so I will, I think let's start the breakout session discussions. The first point I want you to think about clearly are the assumptions of the model. So again, at the end of today's class, I would like you to submit a, in the form of maybe PowerPoint slides, your answers. The first part of the question will be, what are the assumptions of the model that you sort of, clearly lay out? And the second part would be, how do you make empirical connection? And actually, there is no unique answer to that question. And I'm hoping that different groups will come up with different ways to answer that question. And I will be sort of hopping between groups, sort of discuss where you are. Is that fine? So the groups are all ready as we have requested. Okay. Let me just make sure all the groups have the expected attendance. Group 3 has only 4 people, not 5. It did group 3, Chandan, Mohit, Prakhar and Yukta. Did you have a 5th person in your group?
Yes, sir. Rashi.
But I think she was here, but I think maybe she just had a network problem. I did see her a few minutes ago. She had joined here. Okay. And group number 9, were you only 4 people? Arshad, Deepti, Kartikeya, Tanishta? I think you had one more person.
I think I remember that we were only 4 people as
You were only 4 people, is it?
No, Raghuram was in the list.
But I think he had joined too. I think again it might be a temporary network. No, but he is here.
No, I am here. I'm here.
Oh, but maybe somehow he is not assigned to the group. Okay. So okay. When we make the groups, if some of you are left out, we will know where you are left out. On group number 11, again has only 4 people. It must be more, right?
So this is Prakhar from group 3. Rashi left out because of some mic problem, but now she's not able to join.
No,
Okay,
no, she's back now. She's back now.
Okay, cool. Yeah. She called me right now.
She's back, yeah. Okay, 9, 10 and 11, 3 of you, there are only 4 people present right now. As and when people 11, I think Amir is not present. No, Amir must have been there, no? Is that right? Shubha, Pavan, Priti and Sai Priya. I think Amir is not present. Okay, fine. So I'm going to open the rooms now. Okay. And then since I have the list, I will assign you. Okay. So you should be able to join the groups now.
I didn't get any request to join. Raghuram here.
I think you haven't, since you haven't logged in with your registered ID, that's Arun. Arun, are you there? Arun? Shoaib. Can you check if Arun is Arun there?
I can assign him to, which is his role?
No, we can assign, but I just want to resolve the problem once forever. Okay. Why is the registration not happening? Can you just talk to Arun?
Yeah, I will talk to him when he's here. Yeah. So for now, can we?
For now, okay, you can just move him to the right room. Yeah.
Which room?
Raghuram, do you remember what room number is yours?
No, 1 minute, 1 minute.
Raghuram is in ninth group.
Yeah. Yeah, you can move Raghuram to that group. Yeah. Done? Yeah, you must have gotten an invitation now, Raghuram.
No, he already joined, I think.
But he's still okay now. Yes. Okay. Yeah. Okay. You're saying something, Joab?
I think Sanjay was saying something.
Hmm?
He was loud.
Okay. So at least one of us must be around in this sort of main area all the time, because if somebody comes here asking any questions, one of us must be here. So okay. So right now I just will go and drink water and come back for 10 minutes break. Okay. After 10 minutes I will be hopping around. So can one of you be here, Tanveen or Shweb?
Yeah,
Okay, thanks.
Yeah.
I think
thinking through the questions. Feel free to switch on the videos, by the way. I know I would always appreciate seeing faces and boxes with some funny cartoons also. But so is everyone here? Great, excellent. So let me just summarize what I have been going through. I think I was able to visit 8 groups, not all the groups, and I think almost all of you have made very good progress so far. So the first question, about thinking through assumptions of the model, right? I think that's really important, and one thing I suggested across all the groups, and this is something that many of you have done on your own, is the following. When you think of assumptions, there are assumptions in any mathematical model of a biological system. We have made infinitely large number of assumptions. Okay. What is really important for us to write down are what are the most important assumptions that we have made. For example, when if it's a model I'm going to apply to flies, I'm not going to worry how the fly beat frequency is going to affect the birth and death rates, right? So I have actually made lots of assumptions which I haven't even thought about. So the idea is to write the most important assumptions and list them. And what I suggest is, categorize them in the following ways. First set of assumptions are entirely biological assumptions. Okay. And second set of assumptions are mathematical peculiarities. Let's call them mathematical peculiarities. Now think of the first one, biological assumptions. What are the biological assumptions? I suggest again think of them in 3 different ways, which is what are the assumptions we made at the level of individuals? Did we assume that all individuals are identical while writing the equations? Sort of a homogeneous population assumption. What did we assume about their reproductive behavior? Right? What did we assume about the age structure? So those are all sort of at the level of individuals. Okay, and then we also made assumptions about at the level of populations. And of course, even before I go to populations, one can one can also make sure when you're thinking what is a level assumption at the level of individuals or populations, sometimes the categorization might be slightly blurry. Okay, but that's totally fine. For example, will you classify age structure assumption or the sex ratio assumption as a population assumption or an individual assumption? It's not too important, but thinking through this sort of hierarchical ways will really help you a lot. And then think of what's the assumption at the population level that we made. For example, here we assumed a density dependent, a negative density dependence among the populations, right? And we assume that the population is isolated. There is no migration, there is no immigration, there is no evolution. Okay, and finally, we also made assumptions about the environment. Environment, is it constant? Is it changing over time? Or there, as somebody, the seasonality? Did we ignore catastrophic events? Did we ignore stochasticity in the environment? Think of those. Okay, so this sort of hierarchical way of thinking will really help you to see what is the crucial assumption at each scale of organization. Eventually, we are writing a population for the an equation for the population. Okay, but we have made assumptions across all the levels of ecological organizations. Okay, it really helps you think what did you write, what did you miss. Now, once having done this, now think of mathematical aspects of it. For example, people were writing rightly, of course, because we have only discussed one model in the last 1 month, right? Effectively, our logistic population model assumes that the density dependence is a linear decay. But is that a very important assumption? In fact, as I gave you hint in the very beginning, it's not a very crucial assumption. You will find the same result even if you assume an exponential decay. Logistic model requires that your R0 is between 0 and 4. And that's a very peculiar thing about logistic model. It's not really true for many other models. Okay, so do make sure you know about them, but you also need to be clear: is it really important or not important? Another peculiarity will be, or when we write these equations, we thought of population numbers, right? But they have to be integers if it's population numbers. N can be any real number, right? So is that really important again? It turns out that it's really important. All population sizes, but not when you're in very large population sizes. Okay, so that's a useful assumption to know. Okay, and you may not necessarily immediately know implications of each assumption. We'll only learn with time. But thinking broadly on these lines, it helps you think through what are the ecological assumptions you have made, what are the mathematical assumptions you have made, and you may not immediately know which is important, which is not, but it's good to have that clarity. And now when you go to the second part, which is making empirical condition. So now how do you go about this, right? Right? Just ask yourself, where do you typically get data in when studying populations? Broadly in studying any biological system. So broadly there are two ways you can get data. First way would be collect data from the natural world. Okay, now the kind of approach you take to analyze them, the kind of approach you take to make connections with the model will be very different in those cases. Compare it to another case where you can actually do experiments in a laboratory. Okay, so again think through, now having decided which kind of data you may have, how will you go about making connections? What will you plot? From the plot, what will you compute from these plots? And again ask, when we are making all these plots, when we are making connections with the model, there are again multiple ways people think about this. One, you can actually test, are the model assumptions correct? Okay. Secondly, you can ask whether the model predictions are correct, assuming the assumptions are correct. Or for example, have you validated the fact that the model assumptions are correct? Then you can go on and now ask, are the model predictions correct? Okay. So again, these are the sort of multiple ways to think about. Okay, and sort of make connections with empirical data. Okay, that's a broad summary. I just wanted to convey to you all, having gone to each of your groups. So any sort of questions from your side?
Yes, sir.
That others, everybody can clarify their questions and doubts.
Yes, I had a question.
Who is this?
This is Nile.
Oh, Nile, please switch on the video. Thank you.
So my question was this: you said that the fact that R0 can take a value only between 0 and 4, or 1 and 4 for that matter, is an assumption you're making. But isn't that a consequence of the model you're using?
Yes.
So why would that be an assumption?
Yeah, so you're right. It's not it's not necessarily an assumption. You're right. I think what you are saying is perfectly valid. I would just call it a model peculiarity in some sense.
Okay,
because of that, we are forced to assume that R0 has to be between 0 and 4 for if this does apply to any real system.
Yeah.
Other questions?
Yeah, I have a question.
Who is this? Akash.
Akash, yeah.
Again, stay on the video if possible.
You to come up with experiments and plots to validate the logistic model specifically, right? Or in any model in general?
That's up to you.
Okay.
So does it make sense to say I want to validate logistic? What does it mean? What when you say I want to validate a logistic model?
How? I know. Maybe not quantitatively, but vaguely how well it can predict what the next time step would look like given a set of conditions, in some sense. So like what we're trying to do with population models is just seeing which of these models fits reality best, right?
Okay.
Okay.
But those are slightly different questions. All of you have studied pendulum in physics. Okay. Which is simple harmonic motion, right? And simple harmonic motion, although there is a real simple harmonic motion we study, for a large number of physical systems, we assume that simple harmonic motion is a good approximation. Isn't that right?
Yeah, true.
It doesn't mean that the model actually follows the sort of exact equation of simple harmonic motion.
Okay.
Right? And then what we often do in those cases is that we assume this simple case of let's say a particle in a simple harmonic let's say well, and then it's moving, and we sort of measure various, think of various, we sort of make lots of predictions about the system. Now, how will you now go back and think experimentally about this? So one way to do that is actually construct ideal simple harmonic oscillators, and then make the kind of connections that was also there in the theory, right? And then see if that really happens again in the real system, right? So that's one way. For example, you engineer a system which exactly mathematically represents like a logistic model, and then see if there is a parameter R that you can sort of manipulate and find all these properties. So in fact, now that we mentioned harmonic oscillator, I don't know how many of if there is a simple harmonic oscillator just does this, a pendulum, right? Imagine if we have a pendulum connected to another pendulum. So basically the hinge of the second pendulum is on the bottom of the first pendulum. So this coupled pendulum actually also shows chaotic behavior under some conditions. Okay. Now in physics, the easy thing is you can actually vary those parameters fairly in simple ways, and that just becomes much more difficult in a biological system. Okay. So one way to do engineer a system that looks exactly like a logistic model, and then see, do you actually find all the properties that the model actually said it will.
Okay.
Now another philosophy is I don't believe in engineering. I just want to observe what happens to what the real populations do.
Yeah.
Right. Okay. That's a different way of making empirical connection.
Okay.
Pranav, we have a question.
Yeah, I had two questions. One is related to what Vinay said.
Yeah,
which is
please switch on the video if possible. Yeah.
So one is related to what Vinay said, which was that, which came up in our discussion also. We're talking about the assumptions versus properties. So is it also helpful to look at it that way as like assumptions before we construct the model and then deriving properties from that? So is it also helpful to separate it that way?
Assumptions before. So if you are, let's say, now trying to model some bacteria species, right? Then you will make very specific assumptions relevant to the bacterial system.
Yeah.
Right. So on the other hand, if you have a general model like this, then you will have to now think of a system that will sort of broadly meet many assumptions.
Yeah, sure.
So for example, obvious example would be, you shouldn't pick elephants to test the predictions of this model. Why? Can anyone tell why? For example, if somebody does come and tell you I have 100 years of elephant population data, can we think of it as some sort of can I use this discrete time population model framework? I say no, that's a very bad idea. Why?
Their lifetime will be one time step.
Huh?
Their life will be one time step. Sorry.
Well, it won't be one time step. It will be few time steps. Elephants have a see the lifespan is not same as generation time. Distinguish the two. Okay, generation times are often much smaller than the lifespan. Okay, for example, humans 25 years might be a generation time, not the entire lifespan. Okay, likewise, elephants will be again of the same order. Okay, I think biologists, wildlife biologists here will know better than me. That's one reason. Okay, you have very small number of generations, but there is a more fundamental reason.
I can think of age and sex structures, gender, sex structure. Sorry?
Sorry, was it Pranav, by the way, who is speaking? Pranav, right?
Yeah, I said I can think of age and sex structural.
Yeah, so thing is, the age structure and the sex structure we have ignored in this model is just way too important for elephants. So it's, the age structure is just way too important to be ignored at all when it comes to elephants. Okay, that's the second reason. One is we will have very we have 1 second. You have very small number of generations. One, you have only few data points. Secondly, you have age structure, sex structure, difficult to ignore. A third reason. Can you tell me the third reason why elephants are a bad example again?
Population densities.
They're very small or large. What
Yeah,
about
very small. You
They're very
you don't have them in large enough numbers for this model to be a very good approximation.
Yeah, so that's not as much of a constraint, by the way, but it's possible. But what you're saying is a constraint. In a given area, the numbers might be small. Okay. Yeah. For example, if you wanted to model elephants in Bandipur, Nagarhode stretch, that's about several thousand elephants, I think, if I'm right. Maybe 1 or 2, thousand elephants. That's actually not a bad number. But the problem there really happens is the fact that the one that I was alluding to is the fact that there is nothing like a close. It's hard to think of a closed population for elephants. What's the appropriate unit where you can consider a closed population for the elephants? They move around so much, okay, that a closed population one has to think carefully. Think of a really big landscape as one huge landscape as sort of a closed population. It will introduce its own peculiar issues. Pranav, you still have your hands up. Any questions?
Yeah, I just wanted to. The reason I asked that earlier point was because I was thinking that it might be useful to separate out maybe assumptions that we make and insights we derive from the mathematical model. Because maybe if we treat the properties we derive also as an assumption, it might, for example, that it bifurcates in the way that we looked at it. So it might be more helpful to fit systems to more fundamental assumptions, like what we like in constructing the model, rather than properties that come later in derivation.
Okay, so you're saying that the match between empirics and the data must happen at the assumption level of the model building. Is it right?
Yeah, that's what I.
Perfectly well. Yes, absolutely. Yeah.
And I had another question also. So, like,
when people are doing research, they're doing it for many reasons. Some people want to do experiments which are closely tied with theory. For those people, they're not necessarily interested in understanding. What are the so I also mentioned this word called model system sometime in some group. I hope all of you understand what is meant by a model system, right? So model system or model organism in biology. By the way, as I had mentioned in the beginning of this, if possible, do switch on the videos whenever you don't mind. Of course, entirely optional. So what I was saying was that in biology, you often see people across labs studying very similar organisms. There are people who study, E. coli, yeast, Drosophila. But maybe a handful species if you put all of them together. But if you think of the diversity of biological systems, it's massive, right? But people do choose a small number of species to sort of test their hypotheses and build ideas, right? So and that comes from ease of experiments, ease of handling, right? And also generalizability, as somebody mentioned in one of the group discussions. Is the property of the system so peculiar that I can never generalize, or is it actually a good representative for the entire sort of biological world, right? So for those who are, when you think of more mathematically inclined studies, you also can choose your system that fits best with your the kind of assumptions you have made. So because you are not my goal is not to study Drosophila, my goal is to study population dynamics. So I can ditch Drosophila and move to some other insect if it actually fits better, with the theoretical predictions, right? So that's something to keep in mind. Okay, so we can choose different model organisms based on the questions we have in our mind, and what's the model predictions that we have in our mind.
But if you're choosing a model organism to fit your predictions, aren't you already giving up on the idea of generalizability? Because you
There's
want
always this tension, this tension between choosing a model organism and uh, generalizability. Yes, you're right. But it sort of makes a point, it sort of shows more of a proof of principle. Okay, now I had this mathematical model that made these predictions. Hey, I can actually demonstrate this in the lab. If I can't even do that, there's no hope of doing it in the wild, right?
okay.
But what about the opposite case where you have a system and you have a question and you're trying to use modeling or a mathematical approach to generating your hypothesis or generating a prediction that you then go and test?
Absolutely fine. For example, imagine that you were studying some insect species and it so happened that the equation that came out of, so we had some insect species and you made assumptions about the equation, reasonable assumptions based on your previous knowledge, and the corresponding equation was maybe the logistic model. Okay, and then you made predictions. Okay, now then you go back and test. Oh, hey, look, this is making all these predictions about what will happen to the future populations, right? So now I can actually again go on, test these predictions. It provides now various hypotheses now, for medium to sort of low to medium growth rates, we will have stable population, equilibrium populations. For intermediate growth rates, we will have a cyclical population densities. Whereas for high population growth rates, we may even have chaotic behavior, right? So this modeling framework will give you these potential new hypotheses to sort of think about. Okay, fine. I'll stop here. I want you to go back to your groups now and finish the second part. I hope I have given you enough points to think about. But keep these two in mind. Whatever you choose, when I say empirical connection, think about what are you going to measure, what are you going to plot. Okay, keep that in mind, and then what aspect of empirical connections are you trying to do? Okay. Okay, excellent. Okay, so go back to your breakout room. So I'm hoping that this you should be able to finish by 5. Do you need do you need time beyond 5 p.m. today, or will you be able to finish by 5
No,
itself?
we had a lot of time the first only. We come did a lot of.
So you need more time?
No, I guess. I mean, I said.
Oh, is there any group that requires more time than 5 p.m. to submit today?
Like for the presentation, can we have it like last week, the next day, 2 p.m. or 11 p.m. or whenever? Because just to organize it and make it properly, we'd like to
See, because some people also had a problem with that because they felt that coordinating is a bit difficult. So if I say 2 p.m. tomorrow is submission time, of course, those who can finish and submit by today is totally fine. So it's just that for those who may have had other issues and delays, I don't want you to be constrained by time. So I'm going to give up 2 p.m. tomorrow. Is it fine? And then please submit before that. Is it fine? Okay. So I'll try to make one more round with all of you before before the end of the day today.
So do we submit it like the previous ones as a presentation, or can we submit it as a Google Doc or a Word file or something like that?
Just keep it, you can easily convert them to your presentation, right?
Sure. No problem.
Yeah. Let's have a single format for everyone.
No problem.
A PDF, but a presentation format. Is it fine?
Yeah,
okay.
That's fine.
Okay, thank you. Bye. So I'll just start the breakout. Sean, you seem to be stuck here.
Yeah, I'm not
Sean
sure
and
what
Pranav.
happened. Yeah.
What
I was
happened?
just typing another question in the chat box.
Uh-huh.
So I just finished typing.
Yeah, my Zoom sort of just exited and rebooted, so I'm not sure what happened.
But you have been assigned the room, so you just have to join. Let me see if I can. Oh, you are already assigned.
I figured it
so...
out. I figured it out. Yeah. Yeah.
Okay, yeah. You should